Hey guys, how's everything going? This is Jaser. Today it's a new episode on the React internals deep dive. It's useId, this new hook from React 18. Actually, I have never used this hook before. I'm sorry to say this, because useId is more related to the hydration with the server-side rendering stuff. And because in the previous work I'm doing, we were not putting our effort in the server-side rendering. We don't have that, so we don't have this issue with this unstable ID. But we're using some CSS and JavaScript libraries on dev. We have this kind of issues. We will often see those errors from the dev console from Chrome. So yeah, the useId is a perfect tool for us to address such issues. In today's episode, we will start with a problem statement, what kind of issues useId tries to solve, and maybe we can try to try with our own solution, and then dive into the source code of useId to truly understand it. So here's the problem. So it's really like a very niche case on the HTML world is like the label elements. For input, if we have a checkbox, the clickable area is quite small, right? And there's no indication about what this checkbox is doing. So usually we'll have a label for it to tell the user what this checkbox is for. And naturally we would like the label to be clickable, right? So this HTML has this perfect attribute called for. If we set the for some ID and the input has the same ID, then the browser, the HTML engine will treat these two like somehow connected. So any click on the label will be triggered on the event input as well. So it's perfect for our use case. And in JSX, because in React we are based on the JavaScript, the for is like a reserved keyword. In JSX we use HTML4. So far so good. So the problem now becomes how we can choose ID for this label and this input. The natural way of doing this, maybe most of the time we're doing it with a global counter, right? So we can create a function. Each time it is called, you will return us a new unique ID. So like this, if we can get an ID, and this ID will be the same for label and input, so we can safely use it. So this approach works, but there's one caveat, maybe two. For now, we're talking about the first one, is that the ID is not stable. Anytime a component is rendered, we will call this ID again, and every time get ID is called, it will return a new ID, right? So even though the change of the ID doesn't trigger the perceivable update on the UI, it's actually the update is unnecessary and possibly will drag down the performance. So we would better avoid them. So the ID must be cached depending on based on the component. That's why we can use a useState hook to store the ID. And this get ID now will work as an initializer. So anytime with this useId is called, we will get ID, and this ID will be returned and also be cached based on the fiber node. So we've used ID here, no matter when you're rendering, unless this component is unmounted and mounted again, the ID will be the same. So the ID will become stable. So we're solving the problem. It's perfect, but there's still another caveat. To explain this, we need to recall what I've explained in the episode about progressive hydration. I think it's episode 30. You can read the post from my JSO.dev or just watch me explaining on the YouTube video. Search on my channel. I think it's there. So simply put, when you're doing hydration, it means like server will generate a piece like HTML, and when you get the JavaScript code, rather than creating the HTML again, you're trying to reuse the HTML, right? But there might be mismatch. So you would like to try to use them if they're matched, and if they're not matched, you will fall back to the client side and just ditch the server-side rendered HTML. But there's one thing called suspense. Maybe some part of the React tree is lazily it is async. It's not synchronous. So for this kind of hydration is called progressive hydration. It is that the server will generate in batches. So it will return the HTML anytime it can, as much as it can, and leave those suspenses like a suspended part to a second batch, and then when that is ready, it will asynchronously send the HTML over the network to the client. So for the client, will receive, you can think of like a piece of paper, but no, a piece of like a document with some holes in it, and it will like over the HTML streaming API, it will get the contents of those holes and then put the contents in the holes, and then try to hydrate on that new content in order. So yeah, so for spans on the server, it will throw the promises, and if the user ID is used in those different chunks, different batches, even though we on the tree structure, use ID here, like for suppose there's 3 use ID here, even though this use ID is sooner and the user ID in the React tree traversal, but the actual order of this evaluation of this use ID function is not determinate. It is not deterministic because we're talking about the progressive hydration case. So this is dynamic. It really depends on the first one, when the server will generate the response, and then the second one is how good is network. So really, there's a chance that even though the use ID is later on, this use ID is later, traversed later than this use ID from the tree structure, the function itself may be evaluated sooner because the response arrives on the client sooner. So this is very difficult to solve by themselves because React doesn't expose us with this kind of lower level API for us to hook into the React internals. That's why the user ID is provided by the React. Now, the user ID solves this is it will generate ID based on its structure, because it doesn't relate to the order anymore. It's not a global counter. So for this use ID, no matter when it's evaluated, it will generate it based on where it is. Like same for this ID, same for this ID. Maybe this is the same. This is the only stable information we can get in a React app. I don't know, but it feels natural to do so if you look at the original pull request. So the idea is clear now. So this hook will generate an ID based on the position of this fiber node on the tree structure, on the React tree. Great. Okay. Okay. So to begin, I'd like to point out that the hook for a React tree, for a React application, the use ID will be evaluated into different runtimes, I would say. If the client is called fiber hooks, but this React tree might be rendered on the server, right? It's called React. I think it's called React face hooks. So different based on where those hooks, the application is rendered, the hooks might have different implementations. So for this use ID, the implementation, like in server React face hooks, must be the same. At least the result must be the same. Like the idea must be the same with the client-side version, so that they can match, right? Otherwise, it's meaningless. So we'll focus on the client-side one in this episode. The first one is mount ID. We're already familiar with this kind of the structure in the React app is that for the initial mount, called mount something, and in the upcoming re-render, it will called update something. So for use ID, initial mount, we'll look at the mount ID. The mount ID is actually just like two things. The first one is get the tree ID. You can see that here. This is the guard for, because this is only for hydration. So If this during hydrating, we'll do something like this. If not hydrating, we will fall back to the global counter. It's actually what we're doing actually. Okay. For the hydration, there are two things. First one, get the tree ID. We will soon dive into where this ID is generated, and then it will do some I think it's normalization or add some prefix, and then return the real ID. For a component, you might have multiple user ID in one component, right? So that's differentiated by the local ID counter, which is here initially at 0, and it will increment here. Increment anytime a user ID hook is used, and it will be reset to 0 in the after the rendering of a component is done. So this means first user ID in one component, it will be local ID here will be postfixed with this h1 maybe. Oh no, 0, and then h1, h2, something like this. But this is the most important information called tree ID. Okay, and the updated ID is pretty simple. So for mount ID, we create a hook and then set the ID to the memory state. So for updated ID, you would not regenerate the ID anymore. We can simply use it. So you can just return the ID from the hook. It's pretty simple. And for get tree ID, it gets from some global variable called tree context overflow and tree context ID. Don't worry about it. We'll soon we will see how these two variables are updated. So actually, everything is under this push tree ID info. This push tree ID, where is it? Where is the push tree ID? Yeah, this push tree ID is the logic where the ID is generated, and the push to the stack. For the stack part, I think we need to point it out somewhere, but yeah, let's ignore it for now. The thing is, remember this is the React tree. So you think when we have this use ID, the tree ID information is already stored in a global variable based on the path to this use ID. If it is switched to another path, like to the sibling, the information here will be if you think about a stack, will be popped, and then it will push to a new ID for this new use ID. So if you are familiar with the tree traverse algorithm in a common JavaScript algorithm interviews, you will be, I think, pretty familiar with this kind of problem, right? You need to get the path. You need to do some DFS and to return the path. To do this, you need to maintain an array holding the path, and every time you move to another subtree, you would pop the elements and push the elements for the stack. So this stack is basically the same. So the push tree ID is where you push the elements to the stack, right? It is done in several places. This here is an example. The most important one is the being work, which is the core function, I would say, in the reconciliation in React rendering. It is supposed to use for the initial mount and update. So here, if you look at this, if it says if it is hydrating and also this fiber is not the one fiber, it has siblings. Basically says if this is hydrating and it has siblings, then we will push the position information of this fiber to the stack. This is what it is doing. You see, number of forks is means how many siblings, including himself, are, and this slot index is the position. It will push this into the stacks, and it will be processed later. Like for this one, and also this fork child is based on the flag, the fork which is add in the place child. This is for reconciling the children, not the one single one child. For single child, a place single child is used, so there will be no flags for this. Okay, and also the push tree ID is also called in push materialized tree ID. This this function is called in several places. For example, it is used in update function component and amount in determine component. This is for initial amount. This is for the re-rendering. It's not that complex. Just keep in mind this push tree ID here. It says it will, because it is single, right? It's single, so the slot index is 0. If it's not, it will push the ID like this. Yeah, update because update function component is always for 1. Yeah, and after this it will do the reconciliation stuff. Great. Okay. One thing I need to point out is like if you look like the a flow, the control flow, the flow of this function is that we push ID in the beginning work, right? And when we are getting the tree ID, it's just it does nothing. It just to get the information from the stack. So it means that when we are pushing the tree ID, it's actually pushing the information for the next call of useId. Because let's say because the render the render of the function is actually inside of the update function component, and push materialize to tree ID is actually after that. And use ID as a hook, it's inside of the render with hooks. Yeah, it's inside of the render hooks and then the push tree ID. When you are calling useId inside of render with hooks, you're getting the stack information from previous one, right? And then push a new one. So you're pushing the ID actually for the next call. Let's dive into the push ID. There are quite some calculation, and this one is optimization. Let's take a look at the normal path here. You don't need to worry about the details about each variable. We don't dive into it. Just remember these two lines. The first one is slot with this shift operator. It basically means times multiple, and this one is plus. So if we think about these two lines in the 10-based number system, it means the slot, which is a position, times the base length, how long is the ID, and base the 10 times it, and plus the base ID. It basically means put the slot info to the left of the ID, right? Add it to the previous ID. So the ID, if you read the ID from right to left, it basically means where its parent is, and then where it is. So that simple. And for the number 30, because for number, if it's too long, JavaScript is not able to handle it. Because eventually we will use this string version. We can cache the result. This is kind of like a performance improvement, code improvement. This is pretty easy to understand because let's say if we have this binary form number, if we get the string format based on 32, it will give us G, right? Because for 32, every 5-bit will give us a result. Like this means it's expressed in is transformed into G, and if we add 1 to the left, it doesn't change the lower bit. So it means that every 5 bits we could cache the result, right? So this is what it's doing. Every if it is too long, we will cache the pre-calculate the result and cache it, and then every time we only need to handle a shorter bits. Great. So actually, basically that's it. If we recall what it is, it's like every time we would if we meet some useId, we will get the info from the stack, and then put its position to the left of the ID for the use of next useId. That is just like this, pretty simple, right? We won't dive into the details about this bitwise calculation because I hate it. I don't want to spend too much time on it. We just need to understand the basics about useId, and I think it's enough. At the end of this episode, this is interesting. Let's take a look at some real examples. And I need to point out that the 0 here is actually not the ID. As I said, this ID is the tree ID information. The real ID returned by this hook, it will be calculated with some prefixes and postfixes. It's more complex, but this tree ID is the most important one, and we will use the this is not the real data, but the core data with 0 and 1s for us to understand easier. So if you have the JSX like this, div with ID inside of it, useId hook is used, then you will generate something like this. This is because, as we said, this one push tree ID is for the next useId. This one, it will get the initial one, which is empty. For empty, 0. And then we have added a child to it. So what we have now? So for this one div, again, it's single child. So we don't have, it's not critical. It's still empty. But after it, you will push a new ID for the next UID, right? And recall, one thing I forgot is that every time we create a new useId, like I think it's here, a leading one is added. Here, yeah. You can see that this one is add the 1 to the left. This is to differentiate the useId. Otherwise, if you don't add them, like say here, if you don't add them, this one will get 0 as well, right? Then we cannot tell which one is which. So for each layer, we add a 1 to the existing ID. So this one is empty, and after it will push the ID with 1 to the empty. So the stack will hold 1 now. And when rendering div rendering this div ID, it will get the 1 and get it and use it. And so after it will just put another 1 before it, so it's 1 1. So it's render 1 here. If we as I said, if we have another child, it will use the ID 1 plus an extra 1 pushed from this div. Cool. So you get 1 1. So now let's take a look at something a little bit different. If we have have two div as siblings, what we have, as I said, because this div with ID it has siblings, so its position cannot be ignored. It's critical now. We need to tell the position for each div. So when we are rendering this div, it will push for each child. When we're rendering this, because it's not a single child, it will push, like the code is here. It is not a single child. It will push the slot index to the stack. So it will push its index, which is 1 and 2. Remember, it's 1 based, 1 2 to the stack. So when we are rendering this now, again, remember that the push is done actually in the beginning work. So now, when we're rendering it, it actually has the context information. So this will actually return 0 1, but the needing 0 is not critical. So you will see that it has ID of 1, and this one is ID of 2. In binary form, is 1 0. So yeah, it has 0 1 0. Again, let's take a look at this example. If we have an extra child inside of this div ID, for why we are having this one? Do we have a? I think there's some. We can ignore this one. I'll update it. Let's suppose that this extra div here. So we have 3 div here. Then this first one, as we said, the position is 1 2 3. So 0 1 1 0 1 1. This 3, right? And for this one, it's single child. it doesn't, its position is not critical. It will use the ID from this div. As I said, this div itself is 1, and it will push an extra 1 before it and for its children. So its ID is 0, 1 plus an extra 1. It will be used in this div. Cool. So now let's look at the last example here. We have two. If we have two div inside of the first div, what do we have? Well, let's take a look at an example. Obviously, for this two div and div, we have 0, 1 and 1, 1. And this, again, for this two, it will have an ID of this 101 because this one is injected, pushed by this div. So 101 is the base they have. And now for this, it will add 0, 1 to this as well. So 0, 1, 101. The leading 0 will be ignored. And this div with ID will be 11101. No, 10101. This is 2. And this one is a separator. And this is 1. Clear, right? Okay, so that's useId. I think we don't need to remember this kind of complex calculation. Just to remember, useId will generate an ID based on the position of the fiber in the React tree, so that if we get it right on the server, no matter how complex the progressive hydration is, in the client side, it will always give us the right ID, the matching one, so there will be no errors. Cool, that's it for useId. Hope it helps. See you next time. Bye.